Good afternoon, distinguished colleagues. Once again I appear in front of you, but this time with a presentation. And I would like to tell you about the photogrammetric methods of 3D modeling. This is a very popular trend, just as you might have gathered from previous presentations. I will tell you about how we see it, what models can be developed, and what problems their developers are facing. To start with, we can say that we all realize that we live in 3D dimensions. Here I can quote the famous movie director James Cameron. I think Armin quoted him too the year before last, when he said that when he made the third movie already, first 3D movie, he was asked, why did you make a 3D movie? He said, because we live in a 3D world. He made a stereoscopic movie, but we are saying in photogrammetry that stereoscopy is one thing, but 3D, three-dimension is a totally different thing. We are used to having classical maps in 2D form. Very often we also encounter the so-called 2.5D visualization of information, and the difference between 2 and 2.5D is very narrow. We could just say that 2.5D visualization is when there is one Z point to the axis one, but that's another thing, because when we are talking about textured surfaces, one Z point is matched with a number of coordinates. Now, speaking about 3D models, of course their main advantage is geometric quality, is universality and realistic visualization, and better opportunities for analysis. If we look at the 3D information, this is the 2D image of a house, for instance, but when you see a real house shown on the computer, when everything is metrically accurate, then we have a totally new set of data, and then we can move from very conditional mapping to interpreters asking to speak slowly. Okay. Of course, when we speak about 3D visualization of information, this information is much more informative, and here we can see the real objects, understand them better, and describe their behavior and topology and other aspects and properties. What are the challenges that we're facing now in the 3D world? They can be subdivided into a number of groups. The first group would be the regulatory documents. This is a classical example that we're facing now, when the technology is far ahead of our state regulations. I think all companies have learned how to develop 3D images, good or bad, but not a single country has a proper legislation which would describe what 3D topographic maps should be all about, what are the accuracy requirements, what are the requirements for mathematical description, what are their generalization or file sharing format requirements. So there is no single set of recommendations here. The second challenge is unreadiness of the end user to use it. I liked the idea when I first heard it, that the current trend of youngsters, and I don't want to insult anybody here because all of us consider ourselves young here, but not everybody really understands this conditional signs or points of a topographic map. Everybody's gotten used to playing with computer and live in digital reality so much that when they look at a map, they don't really understand where they are and how it works. That's an interesting idea. And also, to the same extent, the end consumer of information works like this. Our state officials also, who develop policies in mapping field, they also think about the maps in certain scale, but they never think that the world is changing, and paper-based maps can be found only in very narrow sectors of human activities, and the rest is has been digitalized already, 3D modeled. That's why we need to prepare users to better understand this information. Naturally, the whole set of infrastructure of how to process the data needs to be put in place, including the software to process it. Speaking about 3D models, also we need to remember that there are computation challenges, huge volumes of information, and high requirements for the CPUs and the how to work with big data when we work not with regular databases but with a totally different structure of data. Now, a few words about the 3D models themselves and their classification. I mentioned the challenges, now I'll tell you what's happening on the market.
So the models vary from simplest, that is where we simulate 3D space, to detailed models, texturized, and all that. So how did 3D modeling develop? The simplest idea was to give a 3D coordinates to an ordinary map. This is still happening, at least in Russia. When they want to put together a 3D model, they say, let's take a 5-story building, multiply 3 by 5, and we'll get a 3D model. To a certain degree, this qualifies for a 3D model, but the degree of detail will be too small. Then came laser scanning. But speaking about the present day, photogrammetric technology has gotten ahead of laser scanning, and the density provided by photogrammetry is bigger, greater than laser scanning. You may not know that the latest SPRS forum, Hexagon, put forward photon scanner, where they scan a surface using a laser beam, trying to get the higher resolution. And architectural modeling is where human beings come into play. Now moving on to 3D topographic models. Now I'm going to say basic things. An entry ticket is the possibility to create dense models, and a lot of software developers try to create object-oriented models that are represented somewhat differently. In the first case, we have to do everything automatically, and in the latter, human interference is required, although automatic processing is also involved. Areas of application are quite wide. In the latter, we talk about the 3D geoinformation system. In terms of texturizing, models can vary. You can color them by adding natural colors, making them photorealistic. We are now talking about photogrammetric methods, right? So we can use UAV images, aerial photos, and satellite scanner images of varying accuracy and resolution. Now I'm going to show you different models and point clouds. Of course, all of this was generated by PHOTOMOD. I'm not going to say that yet again. And we can see various ways of representing 3D models. It could be texturized, 3D texturized. And now, or later, we'll talk about vector models. So this is going to run. It's a model based on different input data. For example, this model was created based on input data from UAVs. This is wonderful city of Munich. We mostly processed nadir imaging. We did not texture sidelines for fear of distortion. This is 10 centimeter GSD for Munich. This is an example of processing spaceborne imagery, but it should be noted that not all programs available on the market can process successfully space images. Surya, Acute 3D, as far as I know, don't work with space data. A Digital Globe has good software in this regard. PhotoMod is universal software. It can have any input data, and it doesn't matter to operators what data they use, collected by satellites or UAVs. By the way, that was the Domodedovo airport. We know this road very well, leading to Domodedovo. I know that foreign tourists also drive the vehicles along this road a lot to the airport. This is how the aircraft show on the images. Oblique imaging was mentioned a lot previously to create 3D models. A lot of interesting and exciting cameras are used increasingly to get textured models. Ultracam spray with 5 sensors has been used, 1 for nadir and 4 for oblique imaging, and this is how a 3D surface model looks. I wanted to show that it visualizes the points as Dr. Reisman showed. These are the points in less format but with much heavier density, and they are correctly colored. Each point has 3 coordinates and RGB info. Speaking about our software, I wanted to show this result as well. Now moving on to vector 3D model creation. To create a vector model, you need a standard set of photogrammetric operations, some of which are fully automated. For example, image orientation, arrow triangulation, creation of DSM, ortho photo, and some operations are automated, but manual interference is required occasionally. This is a metric vector model based on space data. Its peculiar feature is that each object has its own relevance to the code disposition table. So we can delete residential houses, we can delete trees, because we're dealing with a database, and this is the main salient feature of this data, the main distinguishing feature. In terms of and by the way, this is side-by-side comparison. On the right is vector model. In terms of metric information, they are identical. The input data here also comes from satellites. This is one of Russian towns. Pros and cons of both methods of 3D modeling are the fact that there is full automation allows us to reach such effects that no human interference is required. But you have to have computational powers of outstanding proportion. So to achieve this goal, you need to use specialized clouds, which we will discuss later. These models are primarily for visualization or for true auto creation. but you can build a 3D information system on them. This is the place, the same place as Mr. Reisman showed in Jerusalem. So Dr. Reisman, you are always on our mind. And a vector model. A vector model is highly accurate models. The main advantage is that we live in the information system, but it's something you have to pay for, and the price of it is manual operation. Можно и больше, мы ж опоздали с началом. So speaking of vector models, all software developers, including us, think about how to automate processing. And the most popular way of automation when it comes to vector models is interactive operations. In case of PHOTOMOD, we work with the primitives. We select a primitive or an object to minimize the number of points that an operator needs to set in stereo mode. Similarly, it has become very trendy to use Reno terrain software, which our American partners sell. They optimize the amount of points that an operator can. If it's a rectangular object, you can set 3 points, and you can process 5,000 to 7,000 points per shift, and that gives you greater productivity. This is if we use stereo vectorization mode. If we are working with point clouds, let's say we generated a point cloud and we want to shift to vector model, in this case approaches vary. You could work with primitives. You take a tube and then you select a plane in it, or you could use point cloud segmentation. That's let's say you have an address plan or a city plan. You can select houses, for example, in that point cloud, and this way you move to an unidentified point cloud to a situation or representation where you have houses, for example. This way you segment or create an object-oriented model. If I'd like to take advantage of this opportunity and advertise PHOTOMOD a little bit, I'll give you some of the pros. First of all, it's an integrated solution. When you can process any remote sensing input data, be it UAV or space images, and all the way to generating any 3D model in one solution. High accuracy. I think any software these days can claim high accuracy. High level of automation. We try to automate point cloud and stereo vectorization. And in this regard, I can say that one of few software programs which covers both, that is vector models and point clouds. And in this regard, we are unique, I would say, or singular. This is the only solution that comes from one vendor and covering different directions. Since we are the sole vendor, we also have 3D model visualization and converting that data into various formats. Now I would like to talk about how we can use this information. I wanted to elaborate on this too, usage, I mean. So we're talking about 3D GIS creation. And since we don't create GIS, we need to ensure a clear, crisp, real connection between specialized packages. This is PHOTOMOD in connection with Ultravox, which allows you to process the data into something that has all the necessary features, meaning it can work with 3D info. This is what our colleagues at Z Mapping did in London. They use a lot of photogrammetric workstations to receive and process 3D info. This is shadows, sun, telecommunication, propagation of radio waves, mobile station designing, emergency planning, disaster management, planning and understanding pollutions, or, God forbid, radioactive fallout. I hope it never happens in this world. Then planning area development. You see houses coming and going on this picture. This is what our London colleagues did. And creating prototypes of hard models. Thank you for your attention. I think I made it. I did it. Да, уложились вовремя. Даже пару минут сэкономили. Большое спасибо за очень качественный обзор. Думаю, должны быть некие вопросы или ремарки. Представьтесь, пожалуйста, для начала. Откуда вы, какую организацию представляете? I am from Sovzond, Vyacheslav Gutin. Do you know of any examples? Example may be too strong a word. Some ready geoinformation 3D systems. I mean, is there anybody who is starting to work with that? Well, you got me thinking. I think I know of some examples, but nothing serious comes to mind. We're going to have a presentation from our colleagues from Siberia. I think they did something. They did a real system. Alexander Dmitrich will help me out. As far as I know, in Helsinki, there is a serious 3D GIS used for maybe 5 years now. So they really use it, update it. Creating 3D information is a very interesting topic. In 2005, Racurs participated in a project, French project, called BD-TOPA, laying the foundation of cartography in France. Back then, all information was represented in 3D. Each building had height characteristics or attributes. So back in 2005, they had intended to create a 3D database. As far as Russia goes, I can't say that I know of any company. I mean, there are a lot of nice point clouds, but as far as well-functioning 3D GIS system goes, so I guess we are on the cusp, on the threshold of collecting requirements, info requirements for GIS. Yeah, I guess that's for our bureaucrats, but the trend is definitely there. Let me remind you, by the way, that on Wednesday there's going to be a round table to address photogrammetry challenges, and it's something we need to discuss. Maybe you will share your.
Hello, Anatoly Tirsky, Center of Vision Technologies, Moscow. Viktor Nikolaevich, I've looked at your presentation, and the company Racurs has always been, for me, has always been a leader on this. You always tried to think out of the box. You looked at other formats, other developments in the area. The way I see it, you have plans to work with other formats, as long as you don't have any regulations or documents. So there are plenty of formats which do work with 3D information now. And in your presentation I saw that you can import or read other companies' formats. Are you planning to build a universal viewer which might be user-friendly on one hand, and it indeed might be very user-friendly to work with different formats, to work even maybe under your software? Thank you. Of course, we offering the whole pipeline when we get the raw image at the beginning, and we work for everything. Our 3D mode, which is still supplied for free, can visualize, for instance, laser scanning data and do some work with that. It's not classifying the laser scanning data, but in terms of 3D visualization, you can combine within a single software different data. I think that in terms of our development, when we enter 3D, at the entrance we might use not only pure photogrammetry but also other information to make sure that out of all this set of data to build a 3D model. But we're not going to develop information 3D systems because it would be too much a task for us. But in terms of metrics and visualization, and in terms of any measurements, we can do this and combine the data. Хорошо, большое спасибо за вашу презентацию.